welcome to another lecture of the course Aquaculture. Within the major topic of age and growth estimation and its significance in aquaculture, today we are going to talk about fish growth estimation. Growth, as we all know, may be defined as a change in length or weight when we are talking about growth in biological terms. In other spheres of life also, the word growth, the term growth, we also use. For example, we talk of economic growth, we talk of social growth, we talk of career growth. So, but here in biology, we try to document the variation or the change that has occurred in length or weight over a period of time. So, what does this indicate? This indicates the growth may be taken as an indicator for indicating health of individuals in the population, and that is one of the very important parameters for assessing the well-being, health, and success of culture operation or aquaculture or fish culture or any culture you are talking. Then we can also assess the uh, population status in a region in a given aquatic environment, and based on the growth performance of the fish population in a given region, we can also understand the quality of the habitat, because there are a number of factors that directly or indirectly influence fish growth. So, if the fish is showing good growth, that means the factors, the parameters in the ambient environment of the fish in its habitat are within the optimal range, and the fish is showing good growth. It has, it will show good condition factor also and well-being. Now, in case of uh, many animals, especially mammals, we know that the growth stops after a certain age. And no matter how much the age progresses, growth will not occur. But there are examples like fish, where the fish will continue to grow throughout its life. If you can recall, I told you regarding the fish growth in different stages of its life cycle. Then I just showed you a graph wherein during early stages of life, fish shows very uh, sharp growth, and then the growth declines. Like it will go like this, and the growth rate will decline, but will not stop. So, when the fish gets older, the growth rate will slow down, but it will not stop. It will still continue to grow. Such kind of growth may be referred to as indeterminate growth. Now, there are different methods to interpret the growth rate, to understand the growth pattern that a fish population is showing. Absolute growth rate, relative growth rate, instantaneous growth rate, and then a specific growth rate. The purpose is same, to understand the change that has occurred in length or weight of the fish, but the parameters here we are discussing are expressed in a different manner. First one is absolute growth rate. Absolute growth rate, as the term name indicates, here we try to document, we try to quantify the total increment in weight or length, whatever we are intending to assess. And that is why it is written here absolute increase in weight or growth, absolute growth. Now, how do we measure it? How do we assess it? Nothing, very simple. Final weight minus initial weight over time. That means difference in weight or difference in size, whatever you are taking, over time. So over a period of time, what is the growth? What is the difference in weight that has occurred? What is the increment from the beginning, or you can say what is the total difference from the beginning that has occurred over a period of time that you can consider as absolute growth rate? Since growth rate of the fish varies in different life stages, so the growth rate, absolute growth rate, may also show variation. Um, but sometimes it becomes very difficult to um, distinguish between the absolute growth rate of two different stages. It all depends on what are the values on the upper side and the lower side. For example, if the fish, if you have stocked 100-gram fish, initial weight is 100-gram, and it has reached, say, for example, final weight is 1000 grams. 100-gram was initial weight, 1000 gram is final weight. Over a period of, say, for example, 300 days, then what will happen? The difference in weight will be 1000 minus 100, that will be 900 over 300 days. So that will come to 3. But suppose you have taken, this is a quite large fish, 100-gram fish grew to 1 kilogram, 1000 grams. Now, suppose some fish at a very small stage showed, say for example, 3-gram fish initial weight, and 12-gram is the final weight over a period of only 3 days. Then what will happen? 9 will be difference over 3 days. Again, the absolute growth will come to 3 only. So depending on the species, you should not get confused with this. Here we have to understand what is the total increment over a period of time. It is always very important to take into account the time duration and the size of the fish, what you initially took and how much it grew. So it will be over a period of time. So whenever you see the values, always try to understand it with life stage of fish as well as the time duration. Relative growth rate, it is quite common to use this type of growth rate in our indoor experiments, especially in nutritional studies, and we often call it as percent increase in weight. What we do, we simply take weight increment, final weight minus initial weight over initial weight, multiply the product by 100, and then whatever we get, we call it as relative growth rate, or very commonly as percent weight gain or percent increase in weight. So say for example, the earlier example what I showed you, that the fish difference in weight of final and initial weight of the fish was 900 grams, and the initial weight was 100 grams in the earlier slide if you see, and if you multiply it by 100, then what you will get? Here you are getting 900% of growth in terms of when you are expressing this as relative growth rate. So it all depends on how you are interpreting your data, in what terms you want to understand. This is the overall percent weight gain shown by the fish when you are not taking into account the time duration. Then 900% growth. Earlier, when you took time duration into account, then absolute growth rate was represented as only 3. But here it is 900%. The same thing, but here time duration has not been taken into account. A relative growth rate is restricted to the length of time for which it was computed and cannot be easily converted to another time period. Since calculating this RGR, you are not taking time into account, so You cannot, if you develop, if you get the data on relative growth rate, you cannot apply the same data to see a trend on how the fish will perform over a different time period. No. Instantaneous growth rate. Here, what we do, we again take final weight minus initial weight. Now, over initial weight multiplied by time into 100. So, product is that we call as instantaneous growth rate. This is quite popular, instantaneous growth rate, especially in case of small fishes. Aquaculturists typically multiply IGR, instantaneous growth rate, by 100 and express the result as SGR. This is very common expression when you are seeing any of the aquaculture growth trials, whether usually for fish nutrition and related studies. Here what we do, and this is a very reliable parameter in order to understand the growth pattern. SGR percent, in fact, we should write here as SGR percent. Here what we are doing, we are taking final weight minus initial weight, but here we are, we have transformed it logarithmically, and we have taken log to the base e, ln in natural form. ln WF minus ln WI and over time multiplied by 100. So, whatever product we get, that will be expressed as SGR percent. And that is very popularly used in order to express the growth rate of fishes in indoor trials. Then we have many non-linear growth models. In fact, if you have gone through the regression equations, if you have some idea of regression, then you must have studied linear regression and non-linear regression. So, if the data you are having on x and y axis, if it is giving a kind of this pattern, linear pattern, then you can go for linear models like y is equal to a plus bx we express as regression models, or y is equal to mx plus c, in whichever form it is written. But if your data is not like this, if your data goes like this and maybe it shows fluctuations, maybe sigmoid or whatever, if it is not non-linear, if it increases initially, then decreases, then again shows fluctuations, or if increases and then becomes showing plateau, whatever condition is there, you can have then non-linear models. Here, this was just to show you that how we decide. In fact, here also, in case of fishes, the growth is not linear, because as I have already told you that in different life stages, the growth varies, and as the fish grows, it slows down. So, it is not linear. Here, to study growth of natural fish populations, we use different kind of ecological mathematical models, and there are many popular models. There is one logistic curve also which is used, logistic growth model. We have Gompertz growth function model, then BBGF, von Bertalanffy growth function model, which is very popularly used. In Gompertz growth function model, as I mentioned you, there was one more very popular logistic function model. Just like logistic function, the Gompertz function is also a sigmoid shaped saturation curve. That means non-linear. So, if your data putting on x and y axis is not giving you linear trend, then you have to go for non-linear kind of models for any pattern you are studying. In comparison with the logistic function, the Gompertz function is an asymmetric curve. So, depending on the species, depending on the growth performance shown, the variation in the length or weight over time period, you can decide. And it is represented as LT equals L infinity over 1 plus e to the power minus g t minus t0. Here T is, this T0, 0 is a subscript here. It should be here, subscript, right? This 0 is used as subscript. LT is length at time t, L infinity is the asymptotic length, T0 is a hypothetical age at which the fish has 0 length, and G is instantaneous growth rate at T0. So there are certain constants that we will have to calculate first. We will have to calculate L infinity, we will have to calculate T0, and then we can have the LT data, length at time t, we can get, and instantaneous growth rate, of course, this has also to be calculated first. So this is just an example shown here that how Gompertz model is applied. Then comes the more popular of the growth models, von Bertalanffy growth function model, that is applied in studying the growth pattern of fishes in the natural aquatic water system, aquatic bodies. VBGF is probably the most common growth function used in fisheries biology. In fact, it has been applied, for very long time. VBGF has two simple forms, one for length and one for weight. For length, you can have LT equals L infinity 1 minus e to the power minus k t minus T0. It may look similar to the other model, Gompertz. Then instead of length, you can take weight also. Other things will remain almost same. LT and WT are the length and weight at time t. L infinity and W infinity are the asymptotic or theoretical mean length and weight which the fish in a population would reach if they live and grow indefinitely. Again, this is something which you will have to calculate first. K is a growth coefficient. This should also be calculated. Then T0 is a hypothetical age at which the fish has 0 length. Again, this has to be calculated because this is a hypothetical age. So these are sort of constants that you will have to calculate by using the data you have collected. B is the exponent of a length-weight relationship of the form. You must have studied about length-weight relationship, W equals AL power B, or in logarithmic form, you must have studied this as log W equals A plus B log L. If I remember it correctly, then it was after logarithmic transformation, the length weight equation may look like this. And if you fit the VBGF to the collected data of total length and age, what you have calculated, I have told you about age estimation from length frequency method, from hard anatomical structures and other methods. So if you have collected length data and you have got age data also, then plot it and you will get VBGF plot something like this. This I have taken from one of my published research papers where we used VBGF to understand, to assess the growth performance of the fish population in natural environment. What we did, we took 3 species, Schizopyge curvifrans, then Schizopyge niger, Schizothorax isocyanus. We studied these fishes from Kashmir, and here you can say that we calculated, we determined age using otoliths scales, and in one case vertebrae and scales, and we calculated L infinity with the data provided by say for example, for one species otolith and scales, another species again otolith and scales, and the third species with vertebrae and scales, depending on which structure was giving most suitable age reading. I told you in my earlier lecture that by comparing the age data from different aging structures, we decide that which aging structures we should use for assessing the fish age. So accordingly, we have taken this, and then L infinity was calculated. Then this is recorded what we got, maximum total length. Then K, growth coefficient, again it was calculated, and likewise the other data. Ultimately, we got this equation for our fish. This is Schizopyge curvifrons, the first one. LT equals 49.8. L infinity value we calculated 49.8. And then what is this? This one I will show you in the formula, e to the power minus k t minus t0. So here we are having minus k value 2.263, then t plus t0 value 0.34. So if we are having either LT as unknown or T as unknown, if we are having one unknown and the other known, then we can calculate. Here we were having the data, so if you put any age at T, say we calculated using age 1, 2, 3, 4. Now you wish to understand that what will be the length of age 5. So you just put 5, you will get the length. Or you simply put the length here, say for example 10 centimeter, 15 centimeter, 20 centimeter, that is what we got the data. You just put any random data here based on the growth performance shown by the fish when we collected large number of samples to study, to develop this equation, VBGF equation for that particular species, Schizopyge curvifrons, in the habitat from where we collected. So in that habitat, if you apply this formula, you can calculate any unknown length at any known age or any unknown age at known length. So that is the beauty of this VBGF equation, and most of the time it is very reliable kind of data you get from VBGF as far as growth performance of the population is concerned. For Schizopyge niger, we got this equation. You will find that in the value of growth coefficient, and here T0, the variation will be there as well as in L infinity. So the constants will vary from one species to the other, and not only from one species to the other, but from one habitat to the other, even if we are going for the same species. This is the source from where we have taken. The paper was published, and I have taken one part of that. Now, I have tried to show you some of very good and important papers where you can get more information on this aspect, the growth models, the growth performance in aquaculture or in natural water bodies. One is published in Aquaculture, Growth Models in Aquaculture for Hybrid and Natural Groupers based on early development stages. Then a review on fish growth calculation, multiple functions in fish production and their specific application. Again, very good paper. Here we have another paper, Growth Models and their use in ecological modeling and application to fish population. And we have effects of dietary protein levels on long-term growth performance and fitting growth models for carp. Contribution of fish production to farmers' subjective well-being in Vietnam, a logistic model. They have just explained the logistic model. Earlier I explained the VBGF model. So there are a number of models, there are a number of growth patterns, and if you wish to study the simple growth performance parameters, you just go through any of the fish nutrition studies papers. There they will describe the growth parameters in terms of percent weight gain, in terms of specific growth rate and other such parameters where you can understand. FCR is another parameter where we assess feed conversion ratio, but there again we utilize growth as well, how much increase in weight and then how much we have fed the fish. So there are many parameters in order to assess the growth performance of the fish, direct or indirect. There are different factors which affect fish growth. Some of these factors I could have briefly told you, but important ones are food availability. Just go one by one. Food availability, photoperiod, temperature, dissolved oxygen, ammonia, reproductive development or gonadal maturation, you can also say the last one. Food availability. We all know that without food, there will be no energy and there will be no growth. So food availability is one of the important parameters, and getting food in natural environment is something very crucial and critical. So and one more thing I would like to tell you, that fishes, it's not like whatever food you give to them, you provide to them, they will feed and grow. No, there are different categories. There may be they may be monophagous or stenophagous or uriphagous. If they prefer to feed on maybe one kind of food item, but usually this is not successful. So they may be limiting their food choice to certain varieties of food items. So or they may accept wide range of food items. So for the success of any fish culture, or for the success of any fish population in natural environment, it is required that they utilize wide range of food items. So wide range of food items, but still they have their preference, that okay, they will feed on such a kind of plankton, or such kind of a specific food item they will feed upon. If that food item is not available, then they may migrate from that place to some other place where they will get their preferred food item in abundance. Such kind of migration, if you can recall, you must have studied somewhere, is termed as elemental migration. When fish migration is for the purpose of getting food from one place to the other, then we call it as elemental migration. That is quite common in case of fishes, from one place to move to some other place. Especially you must have studied about the plankton bloom. In one season you will find plankton in some certain area, in other season some other plankton species in some other area. So fishes may keep on moving depending on the food. So food availability, the quality of food and the availability of food, quantity of food, both are very important. And if we are doing it in confined environment, culture practice, then nutritionally balanced food should be provided, and that should be provided not in excess, not in less quantity, but in optimal quantities that can be utilized by the fish without any wastage and without any adverse impact on the environment. So food availability is one of the factor. Then photoperiod. Photoperiod, the length of day and night ratio. And photoperiod, we all know that photoperiod influences the growth, not only somatic growth but gonadal growth also, and in fact the overall breeding process is influenced by photoperiod, and overall growth is also influenced by photoperiod. There are certain fishes which will show faster growth rate when days are long, and there are certain fishes which prefer shorter daytime for their better growth. But it all depends on species and the kind of environment where you are doing aquaculture, or where the fishes live, maybe in natural water body also. So depending on the species and the region, the habitat, the photoperiod may influence a lot, and especially the gonadal maturation part and the breeding part of fish life cycle, that is influenced greatly with photoperiod. So photoperiod is again very important, and photoperiod is often related to temperature. Here in our country, we have observed that, you must have noticed that during summers we have longer days, and during winters we have longer nights. So the availability of sunlight, you think it this way, the availability of sunlight is limited in winters, but the availability of sunlight in summers is in abundance. So if the fish culture is being done in semi-intensive system, then the availability of light, nutrients will be required for plankton production. So that such kind of factors may influence a lot. And forget about the production of food that will influence fish growth indirectly by affecting the production of fish food, live foods. But temperature can directly influence the growth of the fish. For example, if you are cultivating warm water fishes, for example, Indian major carps, Rohu, Katla, Mirgal, these fishes are habitual of living, or they have adapted themselves to live in warm water conditions where water temperature doesn't go usually below 20 degree or so. And sometimes during harsh winters, when in the inland regions, especially in the northern part, when we are having water temperature maybe below 10 degree or below 15 degree for quite some time, then what happens? The growth rate of these warm water fishes, which are not habitual of living in such kind of cold waters, they stop, taking food. They will take food only for their maintenance, and sometimes negative growth is also observed. And usual growth pattern is not recorded. I gave you one example of polyhouse, that how we observed growth in polyhouse and the fish kept outside polyhouse. In my previous lecture, you can see that. Then temperature also influences not only somatic growth but gonadal growth also. I gave you example of polyhouse for gonadal maturation of fish also. So you can have that idea from my previous lecture. Then dissolved oxygen also has a strong influence on fish growth. We know that there is optimal requirement of oxygen for normal functioning of the body systems. So in case of fishes, we have discussed it around 5 or so, 5 to 7 ppm, milligram per liter of dissolved oxygen should be there. If the dissolved oxygen goes down, then fish comes under stress. And when they are under stress, everything will be affected, whether feed intake, feed utilization, or fishes becoming more prone to disease occurrence, and many other things are affected. And ultimately, the overall fish growth or overall performance of the fish population which you are using in aquaculture, that is very adversely affected. Same goes for ammonia concentration. In my water quality lecture, I told you regarding that there are some important parameters which should be kept within the optimal range. If we do not monitor them, if the level goes beyond that optimal range, then and there are very adverse effects. The fish will come under stress, and if the fish comes under stress, then everything is affected, including growth. Reproductive development, or you can say gonadal development, because fishes are seasonal breeders. So when breeding starts, gonadal maturation starts, in fact, not breeding. If gonadal maturation starts, then what happens? Say, for example, in the inland regions, when just after winter, harsh winter conditions, just after winter, gonadal maturation process speeds up. What happens? When gonadal maturation process will start, the energy the fish is taking through food, the total energy from the food will have different priority at that time. Normally, what kind of energy partitioning priority is there? That the total energy fish is consuming through food, first it is utilized for maintenance purposes, essential maintenance purposes of the body, and then whatever energy is left, that is utilized for growth in normal circumstances when the fish is not showing gonadal maturation. But as soon as gonadal maturation starts, what happens? The priority changes. Now energy will be partitioned first for the survival or maintenance purpose, then the energy will be channelized towards gonadal development. And if any energy is left, it's not necessary that any energy is left after channelizing it towards gonadal development. If any energy is left, only then it will be utilized for somatic growth. That is why during the gonadal maturation period, the nutritional quality of somatic tissues becomes poor. And in fact, that is because of the requirement of nutrients and energy for gonadal maturation. And that is why I probably told you in my previous lectures that it is often popularized that never eat a fish in the months which do not have R in their spelling. And what are these months? May, June, July, August. So this is in fact the breeding season of these major carps in this region. So this way, if you are not consuming or killing the fish, brooder fish, then you are allowing the fish to breed, producing lakhs of fishes, young ones, fingerlings, fish seeds, and you are also not consuming poor quality of flesh in these months if you are not killing the brooders. You can go for consuming immature fishes. They may not be having that poor quality, but in fishes which are showing maturity, there will be poor nutritional quality. So that's all in fish growth. Thank you so much.